Now that you have installed the Haskell interpreter,
It is time to start learning Haskell.
first thing you need to do is click on the magnifying glass on the top right hand corner of your screen and type in terminal and then press enter. Now that you have installed Haskell, you're ready to start learning it. In order to bring up make sure that you have your okay. Now that you have the terminal window open, you have to type in the command GHCI and then press enter in order to run the interpreter. GHCI stands for Glasgow Haskell Compiler Interpreter, and this is where you'll be doing all of your programming. So the Haskell programming language can act very similar to a calculator. It's a very high-powered calculator, but the normal operations work. You can add things, you can multiply things, or divide, and also subtract. 2 minus 4. And so all those work, but there's also some more operations that you can use. There's exponentiation, so 2 to the 2 is 4, or even 2 to the 2 to the 2 to the 2, and that is 2 to the 16. There's other operations that you can use, including absolute value of, say, -1, or square root, which is SQRT, of, let's say, 2 or 4. There's also more complex things like mod, which stands for modulus, which is the remainder of one number divided by another. So the remainder of 10 divided by 5 is 0. What about 10 divided by 3? That's 1. So even though this is in front, you can use it in another way, which makes more sense, by typing 10, and then if you use the backtick, which is right above your tab key, you can modify it so that you put it in between the numbers instead of in front of them. And that looks a little more visible because that's 10 mod 3. Haskell also has some nice numbers and variables included in its interpreter, like pi, which you can use in your arithmetic, 3 plus pi, or pi over 2. Oops. Now you see what happens when you have a spelling error. So variables like pi exist. They're built into the Haskell interpreter, but you can also add your own variables. So if you want to include the variable e, which is the mathematical number that was named after Leonard Euler, and e has a value of 2.72. Of course, e is transcendental, which means it goes on forever and can't be perfectly represented using computers. But so you can use e in later expressions and even set other variables, like let x equal e squared. Variables can have multiple letters inside their name. It doesn't have to just be one. You can name it some value. As long as that name does not have any spaces in it or symbols inside it. Those don't work. It can also have numbers at the end of it. Something to notice inside the terminal is that if I start typing the name of a variable and then hit the tab key, it will try and guess what I was trying to refer to, in this case some value. This can be really useful when you have long names because it'll complete it for you. What you can also do is press the up arrow on your keyboard, and that will go through your history of all the things you typed so you can type it again. Press down arrow again to get back to where you were. Haskell has some other useful operators built into it, like conditionals. So if you have a variable a and you set it equal to 10, then you can check if a is equal to 10, or if a is not equal to 10, a is greater than 0, or a is less than 0. So notice how these return something called true or false. These are what are called Boolean values. They only have these two values, and they represent the success of a given operation. So the success of a is greater than 0 is true. Another thing to note is that comparing two numbers is different than assigning a number to a value. When you compare two numbers, you have to use the two equal signs, but if you are assigning it, you use one equal sign. And not equals is designated with a slash and then equals. So Haskell has equals, not equals, greater than, and greater than or equal to. A is greater than or equal to 10, but A is not greater than 10. There's also less than. A is less than or equal to 10. So those are the conditionals. Those will check the difference between two numbers. There's also ways of combining conditionals. So if you have A is less than 30 and A is greater than 0, that's true. So this double ampersand right here is Haskell's way of writing and. There's also or, which is double bar, and so the bar is the character above your return key, and that means or. So you can also compare these with normal ones. So true and false, that's false. True and true is true. There's also true or false, which is true, and false or false. There's one more operator called not. So not true is false, and not false is true. These booleans can be useful when it comes to if statements. An if statement works like this. You put a conditional or put a boolean in here. If true, then A, else X. So this was true, therefore it returned A. If it's false, it will give X. And so these can be used to evaluate, say, A is greater than 0. You can do let B equal 15. If A is greater than B, then A else B. And what this does is it'll check if A is greater than B, it'll give A. If A is less than B, it'll give B. So this is a max function. So it returned the greater, and then if we were to change B to this and then run it again, it would give the max of the two, which is 10. So if statements can be incredibly useful. Another kind of value that you can have in Haskell is what's called a list. So a list is exactly what it sounds like. It is a list of values. They are separated with commas and they have square brackets at the end. These lists can contain any kind of value. They can contain true and false. They can have pi and pi over 2 and e. But they cannot have different kinds of value in it. So this fails. Don't worry about what the error messages say. I've been told that a way to think about the Haskell error messages is that they are mathematical proofs, and it's really too much to try and understand for the first time. But yeah, if you are getting an error, it's because you are mixing types, and Haskell doesn't allow that. But so you can also store lists in variables. In this case, we named it x's. In Haskell, it's normal to name a list as a plural. So if you have x's or e's or y's, right? It's so that the person who's using it can know what value is within it, what kind of value, and that's a list. And so these work just like any other variable. Haskell also has a way of making shorthand lists. So if I wanted to make a list of all of the numbers between 1 and 20, I would have to type them all out longhand. Which gets pretty long and annoying. And what if you had to do this for 1,000 numbers, or 100, or anything? It would get out of hand. So instead, Haskell provides the ... operator, which goes in steps of 1 between the first number and the second number. So you can even do negatives here, -20 to +20. You can have incredibly large numbers in here. 1,000 to 1,000, that's not incredibly large when it comes to computers. This is a little too big for your screen. You can include some more zeros in there, and it'll run for a bit. And if you ever get stuck where you're printing out a really, really long list, then you can hit Control-C, and that will stop it. And so what if you don't specify an endpoint? What will happen if you don't specify an endpoint is that you will go forever. Forever and ever. It will never stop printing this list. Unless, of course, you hit Control-C in order to get it to stop. But so that list goes from 1 to infinity, and Haskell is perfectly okay with that. It will have no problem making infinitely long lists and then using them and modifying them. In this case, watch when I put an infinitely long list into a variable. Nothing happened. It's not running forever like the last example. We can type other things in here and it'll keep going. It's because it's not trying to figure out what is in that list, not until you try and use it. And now it'll go on forever until you stop it. But so that is a property of Haskell called laziness. Haskell is a lazy language. It will only do it if it was explicitly told to do it. And that can have some really awesome properties, like infinitely long lists. Okay, what about if you want to specify a step size? So in this case, it'll go from 1 to 5 in steps of 4 until it gets to 100. 1, 5, 9, 13, 17. You can also do that with fractional numbers, so like pi, and we'll go from negative pi to positive pi in terms of pi divided by 2. So it starts out at negative pi, negative 1/2 pi, 0, positive half pi, and full positive pi. So like numbers in Haskell, lists have operators that you can apply to them. So the plus plus operator will combine two lists to create another one. And you can do that with 3 lists in a line, and it will add one to the next. You can also add an element to the front of the list using the colon operator, also called cons, to add to the front of the list. You can add multiple elements this way. But be careful when you try to add to the back of the list. This will not work. It will get an error because that operator only adds to the front. If you want to add to the back, you have to add another list. There are also some operators that work on the whole list. There's sum, which does what it sounds like in math. It adds all the numbers from 1 to 9, or 1 pi dx. It'll add all those up to get the value. And there's also length, which determines the length of an array or of a list. There's also head, gives the first element. Tail, which gives the rest of the elements. Init gives the first 3, excluding the last one. And then there is last, which gives you the last element in the array. And if you want to access one of the ones in the middle, there's the double exclamation mark. So that'll access the 20th element in the array. Notice something important here, that the 20th element in the array is not 20, it's 21. That's because the first element in the array is the 0th element. It starts from 0 and then goes to 49. And this can get confusing when you try and do something like this, when you're hoping you'll access the last element, when really you need to use 49. Okay? And so that can get confusing, but most of the time you don't need to pay attention to that. There's also one that is incredibly useful for infinite lists, which is called take. So normally this would be every single number from 1 to infinity, but instead what you do is you take the first 10 elements from it and ignore the rest of them. And so that way it doesn't take forever, which is also good for things like this function, repeat. What repeat does is make an infinitely long list out of the one thing that you give it. And so take 10 creates 10 ones, because otherwise it would be infinitely long. There are some other important ones. There's a similar one to take, which is called take with, or take while. Take while. What you do is you give take while a function. In this case, we'll say less than 200. And you give it an array, just like take, but instead of ending at a particular number, it's going to take while this function is true. So it's taking only numbers less than 200. And so an important thing to know about this is a function. When you apply a function to less than the number of arguments it takes, it creates a new function with this variable implanted into it, which I understand is confusing, but just notice the fact that that every number is compared to 200, and if it's less than it, it's true. Don't worry about how it does it. Honestly, it's a little bit of magic. There's other functions that have this same idea, like filter, which filters all of the even elements of the list. So this is an infinitely long list filled with only even numbers. You can do the same with odd. And you can just take a couple of them. Take 10 filter odd 1 forever. So that takes the first 10 odd numbers. There's another one called map, which changes the value according to that function. So in the last case, it checked if it was odd, and if it was odd, it kept it, and if it was even, it threw it away. In this case, what it's going to do is it's going to multiply it by 3 each time. Or add 3, or divide by 3, which is interesting, especially when you put the divide sign on the other side of the 3. Because what happens is that it changes it from dividing the number by 3 to dividing 3 by that number. Zip with that takes two lists and combines them with the function in the middle. So this will make a list from 2 to 20 because they're added. You can also multiply them. Or divide them, but we know this one's just going to be a bunch of ones. But so that's how this zip with function works. And this is useful for combining two lists because it'll make a third one out of the result. But so this is incredibly useful, and it can do a lot of things, but it would be a whole lot more useful if you could create these functions yourself, which of course Haskell does allow you to create your own functions. And it looks really similar to creating variables. You say let, and in this case we will create the factorial function, because that's not built in, but you give it a variable right here called n, and that variable n is only available inside the function definition. And so you call it like the other functions, factorial of 5 or of 10. And so I defined it as the product of 1 to n, because that's what factorial is. You can also give it more than one variable, so let GCD, which is the greatest common divisor, equal if b equals 0, then a else GCD of b and a mod b. Notice something interesting about this function is that not only did you use a and b inside this function, but you also used GCD, which is the function itself. So we are calling the function GCD within itself and using that result. So GCD of some incredibly large numbers. It's only 2. But we can pick something else, 144 and 12. GCD is 12. So that's how you can create and use your own functions. In the next video, you will be creating a bunch of functions and piecing them together in order to solve your project Euler problems.